In this video, we will study the procedure to design a pumping system for an elevated tank that supplies water to residences. 1. Calculation of water supply. Determine the daily water consumption per person. It is commonly estimated at 200 liters per person per day. For example, if the residences are occupied by 10 people, we should consider a daily consumption of 2,000 liters. 2. Cistern capacity. The cistern must store enough water to meet daily needs and account for potential supply interruptions. A common practice is to size it to hold between 50% and 75% of the daily supply, depending on the reliability of the water source. For our requirement of 2,000 liters per day, a cistern with a total capacity of 1,500 liters should be used. 3. Capacity of the elevated tank. The elevated tank should provide an adequate reserve to ensure consistent pressure and meet peak demand periods. It is recommended that its capacity be equivalent to 25% or 35% of the daily supply, adjusted based on the specific system needs. For our example, with a daily requirement of 2,000 liters, a tank of 700 liters or the next larger commercial size is needed. Note that some standards recommend tanks not be smaller than 1,000 cubic meters. 4. Pumping flow rate. The pump flow rate must be sufficient to transport the required supply in a reasonable amount of time, typically between 2 and 4 hours. To calculate the required flow rate, divide the daily supply by the number of minutes corresponding to the desired filling time. For example, for a daily supply of 2,000 liters in 2 hours, 120 minutes, divide 2,000 liters by 120 minutes. This gives a flow rate of 16.67 liters per minute. 5. Pipe diameters. Discharge pipe. The diameter should allow a water velocity of preferably less than 2 meters per second to minimize friction losses and ensure efficient operation. To calculate the discharge pipe diameter, use the equation shown on the screen, obtaining the following result. Suction pipe. It should have a diameter equal to or greater than the suction diameter of the pump, with the fewest possible accessories to ensure low suction losses and avoid cavitation. 6. Total head manometric height. This is the sum of the geometric height, elevation difference between the cistern and the elevated tank, and the head losses in pipes and accessories. Add the total pipe lengths, then calculate 5% of this value to approximate the friction losses. The total head required by the pump is the sum of the elevation difference between the cistern and the tank plus the friction losses in the pipes. This provides the following value.